Hello everyone, my name is RF. Welcome to my channel. Today we're going to solve a couple of KVL and KCL problems and try to figure out how to approach different circuits using these two fundamental rules in circuit analysis. Okay, let's begin with this circuit. Find I0 and V0. You might call it IO and VO in this circuit. So, as we discussed in last session, the methods of KCL and KVL regards some concepts. For KCL, we have the concept of nodes, and for KVL, we have the concept of loops. If you remember, the nodes are the intersections of the circuit. So all these black dots that I'm identifying on this circuit are the nodes of this circuit. Before we start analyzing and solving a circuit, we have to figure out the reference voltage. What is the reference voltage? Just like in physics, that you have a reference height, which is the level of the sea, or the reference for potential energy. In circuit analysis, we should also consider a reference voltage. A reference voltage is the voltage of a point in the circuit, which we consider it as zero potential. So when I say reference voltage, it could be any point in my circuit, but I want to consider that point as zero potential. In most cases, if the tails of all these elements are connected to each other, just like this one, I can consider the bottom end of the circuit as my reference voltage. So this point is my reference voltage, which means the voltage of this point is zero. If the voltage of this point is zero, I can very quickly come to conclusion that the voltage of this point over here, let's call this node node A. The voltage of node A, as you can see, is positive, negative VO. So I can say the voltage of point A is VO or V0. Let's start with KCL. If I apply KCL at node A, if you remember, I said try always be consistent in applying your KCL. If I consider I0 flowing out of this node, by the way, all these lines are connected to each other, which means they're same potential. If they're the same potential, the potential of VA, which is the potential of node A, is the same as potential of this point, and it's the same potential as this point, and same potential as this point. So these four nodes have the same potential, have the same voltage. I can consider VA for all of them. For KCL, what I'm interested is the currents flowing into the node and the currents flowing out of the node. So it's obvious that this 9 amp current is flowing into the node. That's an independent current source. I have 9. What else is flowing into the node? This I0 is flowing out of the node. This I0 over 4, which is a dependent current source, is also flowing out of the source. And over here, nothing has been determined. There is no sign of current direction. But I can consider the current from the Ohm's law. We know from the Ohm's law that the current is voltage over resistor. So I want to consider the current of this loop, this far right loop, as, let's call it I1. and I just need to change it as I1. I1 equals, what is the voltage of this resistor? It's VO. And the resistor, which is 8 ohms. So VO over 8 is I1. Again, go back to KCL at node A. 9 amp is flowing into the node equals all the currents that flowing out of the node. I have I0 plus this branch, which has I0 over 4, plus this I1, which I just figured it out, is V0 over 8. This is the KCL at node A. I have one equation, however, there are two unknowns, IO and VO. Can I solve it? No. I need to figure out another relationship between VO and IO in order to solve this problem. Can you figure it out? Let's have a look at this circuit. This point is the head of 2 ohm resistor. And this point over here is the tail of 2 ohm resistor. If I compare it to this point and this point, that's the head and tail of 8 ohm resistor. Is it true that 2 ohm resistor is in parallel with 8 ohm resistor? Do you agree? If the heads and the tails of two resistors are connected to each other, I can say that those two resistors are in parallel. And you know better than me, if two resistors, if R1 and R2 are in parallel, there's a very important outcome, that the voltage of R1 equals the voltage of R2. This is important in this circuit now. If 2 ohm and 8 ohm resistor are in parallel, I can come to conclusion that the voltage across 2 ohms equals the voltage across 8 ohms. What does it mean? I already have the voltage across 8 ohms. Let me just scroll up. The voltage across 8 ohm is here. It's VO. You see here? VO is the voltage across 8 ohm. What about the voltage across 2 ohms? Again, from Ohm's law, I can say the voltage across 2 ohm resistor is V equals R times I. What is the resistor? It's 2. And what is the current? As you can see, it's IO. 2 times IO. Okay, the voltage across 2 ohms is 2 times IO. And the voltage across 8 ohms is VO. Now, I know that V of 2 ohm equals V of 8 ohms because those two resistors are in parallel. From here, I can say VO equals 2 times IO. That's nice. So I have one equation here, let's call it equation 1, and I have this equation here, equation 2. So if I substitute 2IO instead of VO into equation 1, I guess I can figure out IO. So let's very quickly figure it out. Let me just scroll it down over here. So I have 9 amp equals IO plus IO over 4 plus, instead of VO, I want to substitute 2 times IO. So that would be 2 times IO over 8 or IO over 4. I have IO over 4 plus IO over 4. That would be IO over 2 plus another IO here equals 9. That would be 3 times IO over 2 equals 9. If I cross out 3, I have 3 at the right side, and I/O becomes 6 amp. Can we very quickly figure out VO? That's right, because VO equals 2 times I/O. VO equals 2 times 6 or 12 volt. I hope that you guys had it already right before I solve it. Okay, now let's try to find the current I in this circuit. Feel free to pause the video and try to solve the problem yourself, and then unpause it and see if you got the answer correctly as I try to analyze it. So, I start with reference voltage. Again, I consider this point as my reference voltage. Easy enough for this circuit, because all these points are like a wire, and the wire has a very important factor, which is all those points are the same potential. All these points that I'm blacking are zero potential. So I consider the bottom part of my circuit as my reference voltage. In circuits like this, you have to use a combination method, a combination of KCL and KVL. It's not possible to use only one method to figure it out. From here, I can see there is this loop over here. Let's call this one loop 1. And there's another loop over here. Let me call it loop 2. Can I use KVL in loop 2? The answer is no, because in loop 2 I have an independent current source. So I already know that the current of loop 2 is 2 amp, as you can see here. But in loop 1, there are so many voltage sources. There is this independent and this dependent voltage source, which gives me a very good equation and helps me with a relationship between these two voltage sources, because I'm trying to figure out the current in this loop. Let's apply KVL at loop 1. As I said, try to always be consistent in your KVL. If you want to consider this direction as the direction of your KVL for loop 1, you can see that this is a CCW direction, counterclockwise. You may as well consider this direction, but again, you have to be consistent. If you have 3 or 4 loops, you have to consider either CCW or CW for all your loops. That helps you simplify your circuit. So in loop 1, I want to apply KVL. What I have is this reference voltage. Let me start from this point and I start moving toward this direction. What I see is a negative polarity. When I see negative polarity, I just write that, -3 VR. Okay, I continue moving and I reach to this 5 ohm, which, by the way, I don't know the voltage, but I know if the current is I, this current flows into 5 ohm. And based off Ohm's law, I know the voltage is resistor times current. Okay, let's keep moving. I see the positive polarity of this independent 4 volt voltage source. So plus 4. And look at this. The problem says consider VR for the voltage of this 2 ohm resistor. By the way, I know that the current over here is I, which is flowing into this KCL, and I know a 2 amp current is flowing out of this node. Let me just put it here. So I have this node, current I is flowing in, and 2 amp is flowing out. you can tell me what would this current I prime be? So the current I prime, if I consider this node as node A, I have to very quickly apply KCL at node A. I prime would be I minus 2. I have 2 amp flowing out and I amp flowing in. Okay, so for this VR, I know that this is current times resistor. So plus the current is I minus 2 and the resistor is 2. And I reach to this point, which is the same potential as my starting point. So equals 0. That's my KVL at loop 1. But I have one equation and 2 unknowns. What I need is a relationship between VR over here, this is my unknown, and I over here. So I have 2 unknowns. I need to figure out a relationship between these 2. And that's easy because VR is the voltage across 2 ohm resistor. VR based off Ohm's law is 2 times I. 2 times I prime actually, sorry. VR is 2 times I prime. I consider the current of this branch as I prime. So what I need to do is just to substitute I prime equation. VR equals 2 times, what can I write instead of I prime? Look at here, I minus 2. Okay, now let's just put them all in. Negative 3 times VR, which is 2 times I minus 2, plus 5I, plus 4, and let me just extend these 2 into this parenthesis, would be 2 times I minus 4 equals 0. Oh my god, I have one equation and one unknown. Can I figure out I? The answer is yes. Okay, I'm gonna just extend negative 3 times 2, which is negative 6. So minus 6 times I, minus 6I, plus 12, plus 5I, plus 4, plus 2I, minus 4 equals 0. So minus 4, positive 4 cross out. I have negative 6I plus 5I, which is negative I, plus 2I, which is positive I, equals, actually positive 12 plus I equals 0, or I equals negative 12. If I consider this direction, which is assigned in this circuit, that's the correct answer. By the way, if someone asks the real amount of I, you might as well say current is positive 12 amp, but you need to remember, if you want to announce positive 12 amp as your answer, you have to consider the current direction as clockwise. So if we consider the current direction, which is shown in this circuit, the answer is negative 12 amp with this direction. But negative 12 amp doesn't make sense in reality. We know that only positive current exists. So we can say the current is positive 12 amp, but the direction has to be reversed. The correct answer for this problem, just for the sake of solving the problem, is negative 12 amp. I hope you guys all solve it properly. Thank you very much for your time, for watching the circuit analysis problem solving in KVL and KCL area. I will solve more of these problems as long as you guys hit the like button, subscribe to my channel, share my contents if you liked it, and help me help others. And let's all grow together. Thank you very much for your time. Have a wonderful day, everyone.